web version, it'll look similar, but not identical. I'm going to just do this in the desktop version because I have that installed on my machine. If you've got the hard drive space, then yeah, the desktop version is, I mean, fundamentally better because it's locally executing. The web one, right, if your web connection croaks or whatever, then, you know, you kind of lose things. But the web version, and this is one reason why last summer we asked IT to add this to the license, to our license with Wolfram, is it does have a lot of collaborative-y kind of features. Not quite, but almost like Google Docs. Okay, so you can share files, and I can give you guys like a template assignment just with a link, and you guys can pull that in and then do stuff and then give me a link to submit it. I mean, if you do it on the desktop version, then it would just be a file instead of a link, okay, whatever. But yeah, so it has a lot of those collaborative features, and we thought especially with the pandemic and having to deal with remote students who might be in places where there's not very good high-speed internet, to download a 12 gigabyte file might not really work. So it's been the web version has been a nice addition. But I think I maybe mentioned this sort of in passing a few days ago, that we spend maybe 20 or 30 grand on this license a year. So I want us to get our money's worth. Yeah. So, I mean, I think it's worth every penny the product, but and Wolfram has been really good about supporting us, and like basically it almost added very little for us to add the online component to our license. It was like 10% extra, and they're really trying to, you know, help people out, especially educational institutions with the pandemic and stuff. So anyway, all right, so that's my sales pitch for Wolfram. But all right, so let's get to it. Now, I've used this quite a bit as we've gone on, just to graph things or you know, do some stuff. But what I wanted to kind of do today was start to teach you guys exactly how I'm doing, or how we use this for, you know, algebra or calculus-y stuff that we've talked about. And then, because we'll have done this, then we'll have Mathematica as a thing in our toolbox for when we start doing some of the more long computations, like the optimization problems, for example, can get really nasty, and having a tool to double check our handwork or do stuff where it's not possible to do it by hand will be kind of nice. So, so in terms of the standards and stuff, the way that you'll satisfy this one is just with an assignment. Okay, so I'll put together a sort of Mathematica assignment where you'll be asked to do some stuff, and that's all you have to do for that one. Nolan, you might want to look on the left-hand side of that, the table, the little notch that's cut into it where wires can go. Your other left. Your other left. Yeah, it's a little early, huh? Yeah, so that's the one that you will not do with an exam, right? You'll just do it as an assignment. Okay, so let's kind of talk through some algebra stuff with Mathematica, some calculus stuff with Mathematica, how to solve equations, how to do some of the algebra stuff that you might need to do, like foiling things out or collecting like terms and simplifying and all of those sorts of things. So Mathematica, partly because it's a computer program, is very picky about syntax. Okay, so if you put parentheses where it is expecting a square bracket, it's going to yell at you and not work. You have to be very deliberate and careful with your inputs. So so let's just do something like, okay, so the first thing here is when you open up a blank slate, you see basically nothing. And you see that the cursor is sort of horizontal instead of vertical. Hit enter when your mouse is above that, and what that creates is a cell, okay? And it's an input cell. And then over on the right, you see that little, it's probably a little hard to see on the screen, but it looks like a big square bracket, right? That basically tells you what cells are what, and the cells can be sort of organized in a hierarchy, so you could have like a chapter that has cells underneath of it, and then subsections or whatever, right? So you could write an entire book in this if you wanted, okay? Now, cells, by default, when you create them, are input cells, which is where you type code. It's not where you would type text. So if I start typing something like, this is an input cell, you see how it gives me a contextual, do you want to convert this to a text or section or freeform input cell? In this case, yeah, this should be a text cell, so if I do that, it'll convert the type of that cell to text and render everything as text, okay? So if I'm writing something and I want to give you guys instructions, or I'm asking you to give me an explanation in English, I want to see the explanations in text cells where I can actually read them and they don't look like crap, okay? Whereas doing math will be stuff that you'll put into input cells, okay? You can always select a cell by clicking its little bracket thing over there, and if you right-click, then you can do, go to Style, and then there's a whole bunch of lists. So the default one, of course, will be input, right? But there's a whole lot of other ones that you can do, like you can put in code, you can have title, subtitle, chapter, and things like that. So you can kind of organize your document, and so think about this in a sense like Microsoft Word with the world's best calculator built into it. Or maybe the world's best calculator with Microsoft Word thrown on top. That's maybe a bit more accurate. Okay, okay, so can have input cells. And then if I create another cell, we can do some math. So let me just type something. So when I was writing the algebra problems for you guys, right, what I usually do is actually start with something in factored form and then multiply it out, and then that's what I give you guys, right? So I can choose the roots that I want in advance, okay? Now, how do I execute this cell? I'm going to hit Shift and Enter at the same time. Okay, and if I do that, it takes that as an input, and then it processes it, and it does something as an output. Now, what do you think I maybe wanted it to do with my input? Yeah, so I wanted it to multiply it out, but it didn't. It left it sort of factored like that, okay? So if I want to force it to do that, I need to tell it to do so. So the way I could do that is there's a function called expand, okay? Now, all functions in Mathematica, ones you define or ones that are built into it, use square brackets as the thing that designates what's the input to that function. Okay, parentheses are only ever used as grouping symbols, and curly braces are only ever used for lists of things. Okay, so in that sense, it's very organized. And like if you think about how we write math, right, we use parentheses and square brackets and curly braces almost interchangeably in a lot of situations, and that's kind of confusing, right? In the same way that if I wrote something like f of x, now we've beat this out of you guys, but how many times when you were in, say, middle or high school and you saw that, you thought you were multiplying f times x? Maybe? No, you never thought that? Well, good. You're a wonderful person. No. It's a misleading notation, right? And you guys learn through context and whatnot what it means, and you just do it, and now you don't think about it. You see f of x, and you know that means to plug into a function, not to multiply, right? Well, so Mathematica would not want you to do that. It would interpret f parentheses x as multiplication. And if you wanted to actually evaluate it, you'd have to use square brackets. Okay, so when I have my time machine, whenever that comes up, in addition to going back with a sports almanac and a gun to shoot Hitler, right, so I'll shoot Hitler. I'll make a bunch of money with the sports almanac.
So why would you shoot Hitler?
Well, why wouldn't you shoot Hitler?
Because he just wrote the entire war effort.
Yeah, but like, what about if we could just like not have World War II?
You mean like before?
Yeah. If I got a time machine, right, I can be choosy about when I shoot him. Well, or you know what? Better yet, I just like get him into art school, right? Because that's what he really wanted, right? And then I don't have to shoot him. Okay. Anyway, so I would go back in time and I would tell Euler, right? Hey, bro, why don't we use square brackets for functions, parentheses for grouping symbols, and curly braces for lists of stuff? Just trust me, it'll be worth it. And then now everything will be fine, okay? Okay, so if I want it to expand this, then I need to pipe the stuff through the expand function, and there it does it for me. Now you'll notice that the output is maybe not exactly the order that you personally would have written this by hand. What do you notice here that it tends to do? Yeah. Yeah, it goes in increasing powers, whereas by hand we tend to write polynomials in decreasing powers, starting with the biggest. Okay, whatever, that doesn't really matter, but that tends to be how it displays it. Okay, and then let's say that I wanted to factor something. Right, then I can use the factor function to go the opposite direction, okay? Right, okay, so can do some simple algebra like that. There is also a simplify function that if we had something really nasty, then might be handy to use. There's a few esoteric ones like trig reduce, which, because trig identities kind of, that's sort of an art form as to how you work with them. But, I guess for some simplification, this is sort of enough to get the idea. Okay, now let's take this polynomial, right? When is it equal to 0? When x is 3 or minus 4, okay? And that's obvious when you have it in factored form, or because this is a quadratic and we know the quadratic formula. But let's say we didn't know that, or it was something that was really nasty, and I wanted to solve for x, okay? Then what I can do is I can say, take the equation that I want to solve, okay? And you see how I typed double equal there? Okay, I think I've maybe mentioned this before. Single equals gets used in computing to assign the value of something to something else. Double equal is what you mean when it's an actual equation, okay? All right, so if I want to solve, hey, when is this equal to 0, okay, then what I also need to specify, though, is what variable I want it to solve for. Okay, so in this case, there's only one variable, and so big shock, I'm going to solve for x. But if I had a big formula that had lots of different letters in it, and I wanted it to solve for t in terms of all the others, then I would say solve equation, comma, t, or whatever letter, okay? All right, so if I run that, then it's going to give me the two answers, x is 3 and x is minus 4. Okay, great. Okay, so good so far? Yeah? All right, so let's start defining functions. Okay, that's maybe the next thing. So here I have x squared plus x minus 12, but by hand, I would usually say let f of x equal that thing, and then I would ask you, like, to find f of 2 or solve f of x equals 0, right? I would use the shorthand name for f of x. Okay, so how do I define a function? Well, the first time I define it, okay, I have to use f of x, but then I have to put this little underscore there, okay? But I only do that when I first define the function. And that's a sort of a technical Mathematica thing that tells it, hey, treat x as an input variable that hasn't already been defined, okay? So just do that, okay? And then if I want to use the function, I don't have the underscore. Okay, so for example, let's say that I asked, what is f of 3? Or, some number. Okay, if I run those, I get this output is just parroting back what the function was. Okay, great, thanks. And then what was f of 3? Happened to be 0, okay? And now I knew it was supposed to be 0 because of what we did before, but I could plug in any other number there and get whatever I get, okay? And you'll notice that here I actually had two separate lines of input in the same cell. When you execute that, the outputs are going to be done in order, right? So if you've got like 15 things there, all with outputs, that can get a little bit messy. In particular, did I really need it to parrot back what this function was? No. So I can suppress the output by putting a semicolon at the end of a line, and if I rerun it, it still has learned that f of x is this thing, okay? It's just not outputting that to me. Okay, so if I have like an intermediate computation or something like that where I don't need to see the output, I'll put a lot of semicolons. Basically, it helps me keep my notebooks a little cleaner. Okay, good? Okay, what about if I wanted to plot or graph this thing? How would I do that? Well, how about the plot command? Right? Okay, what do I want to plot? I want to plot the function f of x. Okay, but, and this part will be familiar, when you guys were in high school or whatever using your graphing calculators, when you graphed things, what else did you have to worry about? Not just what function you were graphing, but the viewing window. Okay, so what range of x's and y's, for that matter, are you interested in seeing? Okay, now for our function, what should we probably pick as our range of x and y? Well, let's make sure that for the x's we get -4 and 3 so that we can see both roots. So how about we go x from -5 to 5? Okay, so what have I done? I've said what function I want to plot, comma, a list of what range do I want to plot it over, the x's ranging from -5 to 5. Okay, and if I run that, then it'll graph it. And the y values, the range of the y values, Mathematica has basically automatically computed what's probably a good range of y's that you might be interested in seeing. Okay, and so it did it from like -15 to 20 or so, roughly. Okay. If you didn't want that, there's a way to force the y values also, but it usually is pretty good about getting what you think you want, okay? All right, so does that kind of make sense? Oui? No. And notice, why didn't I put an underscore right there? I'm not defining the function, I'm just using it. Once it's defined, you don't have to do the underscore. Okay, that you only do that once, basically. Okay, so I can plot it and then see, hey, big shock. There's a root and there's another root, and they're exactly where we thought they were supposed to be. Okay, now the plot command has all kinds of stuff you can do to make this graph look different. For example, I could change the color of the plot, or I could adjust the scales and all of that sort of stuff. I could make the plot line a little thicker. I could make it dashed, right? I mean, there's all kinds of stuff you can do. But this is good enough, I think, for right this instant. Okay, so, well, we're in a calculus class, aren't we? Okay, so what kind of calculus might we be interested in with this function, or any function for that matter? Area under the curve, okay, so integrals. What else? And we'll do that. Yeah, derivatives, and what was sort of a, since I've got a plot up here, what would be a use for the derivative in a geometric sense? Okay, and what does that allow you to draw? A tangent line, okay? So let's do both of those things. So there's this section below the x-axis from -4 to 3, okay? It has some area. Let's figure out what that area is, okay? Now, how would I write this by hand, what I'm describing? Like, what's the symbol to describe that area by hand? One of these, right? A definite integral, okay? And so what range of x values am I interested in here? I want to go from -4 to 3. That I just made that up, basically, right? Okay, what function am I integrating? F of x. And then what's the variable under which I'm integrating? X in this case. Okay, so that's how I would write it by hand, right? Symbolize. Yes? Oh, good question. So if you go to Palett's Basic Math Assistant, okay. Now, how many of you guys have the web version open? Yeah? Okay, it may look a little different for you guys. Yeah, okay, that's where it is. Yeah. Okay, now, let me show you also the code way to do the exact same thing. Okay, is if I instead said integrate f of x from -3 to 4, or sorry, -4 to 3. Okay, this does the exact same thing. Okay, so you can use sort of notation like you would on paper, or you can sort of make it look codey. Both work, right? And so let's execute this cell and see what we get. Of course, we get the same answer both times. That's a good thing. But let's interpret that answer. -343 over 6, okay, whatever. Do you have any problems with that number? Okay, it is in fraction form, not decimal form, okay? And there's sort of that's good, and there's a good reason why it was that way. Do I know what -343 over 6 is sort of from a decimal standpoint? No idea, okay? I maybe want to know approximately what is that as a decimal, okay? So I can tell it to do that for me. Any other issues with that number? Why is it negative? Yeah, because the area that we were talking about was below the x-axis in this case, okay? And so if I were really wanting to know what the geometric area of that thing was, then what would I do? The integral gives me a negative, but I'd say, oh, well, but area can't really be negative. So like if this was a fenced-in area and I needed to know how much grass seed to use, right, and I needed to know the actual area, then I'd say, oh, well, it should be positive, of course, okay? Okay, so there's that, right? The sign, just, use your BS detector. But let's talk about the fraction versus decimal thing, okay? So Mathematica, by default, does everything in exact form, which means if there are fractions, it will just keep them up as fractions. It doesn't round. If there are square roots, it will leave things in terms of square roots or pi or whatever. It's not going to give you decimals unless you tell it to. Okay, now the benefit to that is that it can do things really, really precisely, but maybe we do want to have a numeric estimation for this number. Now, in a lot of the output cells, it has this little contextual menu, okay? And the contextual menu, well, we might want the numerical value, or the absolute value, or the integer part, or the denominator, or more, okay? But in this case, I want the numerical value. So if I click that, it will tell me what the command to get a numerical value is, and then also evaluate it, okay? So the function capital N, whatever you put into it, it will return its decimal expansion. And it defaults to six digits, okay? So negative 57.1667, okay, great. What about if I wanted more digits? How many digits do you want? Okay. You want 1,000? No problem. Okay. Yeah, right. So, no problem, right? So, if you want more digits of accuracy, you can specify the number after the comma, okay? Yeah. Okay, good. Yep. And you can do this for other things. So, for example, the number pi is just capital P lowercase I. That's the same as writing the symbol. That's handy because you could go into either the special characters or the palette and get the actual symbol pi. But when you're just typing, like, it's kind of annoying to have to go back and forth between a Greek keyboard and an English keyboard. Speaking as somebody who has to switch between keyboards in English, French, Ancient Greek, and Hex, and for a while I also had a Klingon input, but I don't use that one as much, so. Anyway, so I could say, all right, I want to know pi to 100 digits. Well, there it goes, right? Great. Okay, so that's the end thing. Anything else with the integration? Does that kind of make sense? Right? Now, another way that we could have done this, so let me actually go back down to here. If I gave you this problem by hand to do, how would you do it? You'd say, okay, I want to integrate x squared blah, blah, blah. So what would you do to x squared blah, blah, blah? Yeah, how do you do definite integrals? Okay, but you first have to find the antiderivative, okay? So what am I doing there? I can also do an indefinite integral. So let me call fatty f of x, okay, that. And now fatty f is the antiderivative, okay? So does that make sense? Okay, so notice what I did here is I just said, hey, what variable? But it doesn't have numbers attached to it. And so Mathematica says, oh, you want an indefinite integral. Okay, I got you, bro. Here it is. Okay, good? Okay, and so then by hand, what would we do to compute this integral up here? I would plug 3 into my antiderivative. I'd plug minus 4 into my antiderivative, and I'd subtract the second answer from the first, correct? Okay, and so here, if I do that, let's do f of 3 minus f of minus 4, right? So that's the top number plugged in minus the bottom number plugged in, and then it evaluates it, and I get what I want. Okay. So does that make sense? Right? I mean, that's really what it was doing in the background. It just didn't show you all the intermediate computations. Okay? But in particular, like if you did this with your TI, like what kind of graphing calculators did you guys have, or do you have? 84s, probably, or Are you a Casio guy? Oh, okay, TI-84, right? Yeah, so if you did this with a TI-84, okay, the integration, it would do it only numerically, okay? Unless you were fancy or had a TI-89 or a TI-92, because those could basically had like low-end Mathematica plugged into them, okay? So, point being, when you ask it to integrate, it is doing it symbolically the same way that you or I would do on paper. It's just a heck of a lot faster at it than we are, okay? And you remember all the like integration tricks? I mean, like we've only really talked about one of them, use substitutions, right? It knows the entire library of all the tricks that are out there. Okay, so Mathematica is really good at integrating. So it can do all of your calculus homework and show its work and make you a sandwich. Maybe not the sandwich, but yeah. Okay, good. So that's integrals. What about derivatives? Okay, so what would I maybe be interested in with this function is knowing what the derivative is, right? And in this case, well, what is the derivative? We're not idiots. Two x plus 1, right? I picked a polynomial just for the sake of simplicity, but yeah, 2x plus 1. Okay, so let's make sure that we're correct with that and ask Mathematica what's the derivative of my function. So the way I'm going to do that is using the function d for derivative. Okay, and the syntax is d is a function, right? So that's why it has square brackets on the outside. And what do I want to take the derivative of? F, with respect to which variable? X. Okay, and so if I execute that, then lo and behold, we get 2x plus 1. Okay, good? Okay, now actually here's one thing that's cool about the d thing. There have definitely been times where we need to know what the second derivative is. So how could I get the second derivative? Yeah, do it twice, right? I could take the derivative of the derivative. But what about if I come along and I say, I want the 10,000th derivative? Do you want to do d of d of d of d of d of d of d 10,000 times? No, of course not. So what you can do instead is this. Take the derivative of the function f with respect to x twice. Okay, and if you run that, then we get 2, which is the second derivative in this case, right? But if I wanted to do this 2,000 times, okay, what should I get, by the way? 0, because what's the third derivative? So all subsequent derivatives are also 0, but if I'm stupid and do that, then I get 0, right? Okay, so yeah, you can do multiple derivatives easily. All right, so let's combine some of this stuff. In terms of calculus, what might we be interested in? There's a really special point on this graph. Where is it? Or just, like, not numerically, where is it? Like, where should I point? Yeah, the vertex, which is here. Okay? Now, we can find, because this is a parabola, we don't need any calculus to find the vertex. Okay? But what's interesting from a calculus standpoint about the vertex? Yeah, the derivative there is 0. Okay, how do I know that? Yeah, the slope of a tangent line at that point would be 0. Okay, and you guys see then, what are the slopes here? Negative. The slope there would be 0, and the slopes there would be positive. Okay, good. All right, so let's find where the derivative of this thing is equal to 0. Is that cool? All right, so what I can do is I can say solve d of f of x equals 0, or sorry, well, okay, let me build this up slightly. Okay, the derivative of f with respect to x is this. That's a function. Okay, I want to know when that thing is equal to 0, solve for x. Okay, so you see how I put two of these things together, right? d of f of x is a function, and then I built an equation out of it by setting it equal to 0 and saying, hey, Mathematica, could you solve this for me, please? Okay? Is that good? All right, now, what should we get as the answer before we execute it? Like, let's just not be idiots. What was the derivative, 2x plus 1? When is that 0? When x equals... Thank you. Okay. Negative a half. Okay, and, okay, now we have confirmation of that, right? Now, here's another way to see why it's negative a half. What were the roots? Negative 4 and 3. For a parabola, the vertex is always halfway horizontally between the roots. Okay, so that would be another way. In this case, we could have done it, but only knowing that this was a parabola. Okay? Okay, good. So, go back down to here. We now know that the derivative at negative 1/2 is 0. Okay? So, what would be the equation of a tangent line there? Y equals something, right? Because it's a horizontal line at that point. So how do we figure out the something? I need to know the y value that goes with this x value. Right? So how could I figure that out? Okay, so elaborate. What would I do with negative a half? Yeah, just plug it into the function. Okay, so I could say f of negative 1/2. What is that? Negative 49 over 4. Okay, great, whatever. Okay, so now I know the point of the vertex. Its x-coordinate is here, and its y-coordinate is here. Good? Okay, so if I wanted to graph the tangent line, what would the equation of the tangent line be? Just like if you were to write it out by hand. Y equals negative 49 over 4. Okay, what's the general form that we use for writing equations of tangent lines? Y minus, let me just write it. It's all just nubs of chalk, right? So we use the point slope form. Okay, now, Mathematica in general, like, and this is something you guys had to deal with your calculators also. You can graph equations or you can graph functions. Your calculators expected you to have functions, right? Y equals. Okay, so let's just move the y naught over, right? And then now this is a function that you could give to either your calculator or to Mathematica. All right, now in our case, what's the slope? The slope at the particular point we were interested in was 0, okay? And so that means for our equation, this stuff disappears and we just have y equals the y-coordinate, okay? All right, so let me graph that, and in particular, I want to graph it with my original function. Okay, so how did I plot my original function? I did that, right? Okay, how would I plot, what was it we got, negative 49/4? Oops. Okay, if I run both of those guys, I get two separate plots. I get my parabola again, and then I get a straight line again. Okay, what would I really like, though? Yeah, to put these on the same axes. Okay, and I can do that. Let me get rid of this one, and I'm going to say I don't want to plot just one thing. I want to plot a list of things, and then it'll put them together. Okay. The other nice thing about doing it that way is that if you plot multiple things at the same time, it is like smart and says you probably don't want them all to be in the exact same color, because then you can't tell them apart from each other. Okay, and so the blue one is by default the first thing, orange is second, and then it does green for third, and it goes on as there's some order of the colors. You can, of course, override those if you want. But now I can see I've got my tangent, and I've got my function, and that looks pretty tangent to me, right? Okay, so that looks good. Yeah. Good? So let's do this at a different point. Okay? We picked a point where the derivative was 0, which is really important, and as we'll see. But we could have done this at any other point on there. So pick another x-coordinate for me. 2. Okay. So at x equals 2, that would be right here. Well, first off, positive or negative slope. Okay, and estimating the value of the slope is actually a little tricky because notice the scales of the x and the y-axis are very different. Okay, but positive number is what we're expecting, right? Okay, so here's what I'm going to do. All right, so you picked 2. Okay, do you guys accept that what I have typed here, this is what's the slope at the point 2? How do I figure that out? It's f prime of 2 times x minus 2 plus the y-coordinate f of 2. So do you guys accept that this formula that I've typed is really the same as the right-hand side of our point-slope form? Just in Mathematica notation, basically. Yes? Okay, so what range of x's do I want to plot this over? Well, let's just go with minus 5 to 5 as we've done before. Oops. X from minus 5 to 5. And then, ba-bam. Okay, so what happened to the scales here? You notice how the vertical plot range has changed? Okay, and maybe that's good, maybe that's not good. Let's change it. All right, so what was roughly the plot range of our original one? Yeah, let's say negative 15 up to 20. So I can force the plot range by saying plot range, arrow, and so I do dash greater than negative, what was it, negative 15 to 20? Okay, and there it gives me more like what we had. Okay, so you can specify the y range in addition to the x range if you so choose. Okay. Okay. Just for the very last thing here is, and we'll use this. You guys will use this maybe in a bit in the assignment. We also talked about implicit differentiation, right? And with implicit differentiation, you didn't know what the function was. You had an equation. So how do I plot an equation as opposed to a function? Okay, now, in many cases, like let's say, for example, x squared plus y squared equals 1. Let me just take that as an example. That's a function. Is this a function or an equation? Okay. Is it a function? No, because it fails the vertical line test. Okay, if I wanted to turn it into a function, I can't. But I can turn it into 2 functions, and what are they? Okay, what do I need in front? Okay, and that's why it's 2 functions and not 1. Okay, because the plus gives me the top half of the circle, the minus gives me the bottom half of the circle. So I could plot both of those together as functions, that's fine. Or I could plot this single thing as an equation. So let me show you that real quick before we quit. Okay, if you want to plot an equation, you don't use plot, you use contour plot. What's my equation? X squared plus y squared double equals 1. And then what range of x and y do I want to plot over? Well, what's the radius of that circle for my equation? 1. Okay, so, and where's it centered? The origin, right? Okay, so what would be a reasonable range of x and y to plot this guy for, so I get the whole circle? Yeah, -2 to 2, say. All right, so let's go x from -2 to 2, and y also from -2 to 2. Oops, damn it. Okay, there we go. Okay, okay, so that's kind of a quick crash course on this. And so this will mean, yeah, I'll post an assignment for you guys. I won't make it due this week, obviously, because we got the assessment. Well, due, right? And so this will be the only assessment standard that you do not by virtue of working out a problem. You'll have a notebook. I'll give you guys basically a template notebook with some exercises, do this, do that, okay, and then you'll turn it back in, either with a link if you use the online version, or an actual file if you use the desktop version. It doesn't matter to me which one you do. Okay, so we kind of starting to get the idea? Okay, now, the very last thing I will mention, and for the fact that we are all men, we are genetically predisposed to not do what I'm about to tell you. What is that? Have fun? No, come on. Read the manual, right? There's a fantastic documentation with loads of examples and sample code and stuff like that, right? I know that, like, when you go to Home Depot and you buy some power tools and you open them up out of the box, what's the very first thing you do? Throw the instructions in the garbage.
Well, I don't throw them in the garbage. I just toss them aside.
Okay, but point being, like, we never use them, right? Okay. Not here, right? So throwing away the instructions is just an example of the patriarchy and the fact that you guys are just steeped in toxic masculinity or something, something, something. Right, okay. No, the documentation actually is really helpful here. So resist the urge to not use it, okay? All right, have a fantastic rest of your day. And I will see you guys on Friday, bright and early, for assessment number whatever.